Hello, DotNext. How is going? Do you like the conference? Yes. Good, 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 good. We are here to talk about one of the most important topics of the last months because we have seen that Microsoft finally released the 3.0 version of .NET Core, which is very important because improve a lot of the whole experience for us .NET developers. And so let's see immediately what it is. I am Raffaele. I come from Italy, so you can recognize my strange accent, the way I wave hands on the sky. That's typical from the Italians, by the way. And I am a consultant, so I have a lot of experience in different areas. And I was talking with some of you yesterday night with a beer about the experiences and the strange things that happens when you see the same exact problem, but from different perspectives. And I love to bring this experience in stage and trying to build simple but effective demos that can demonstrate the most important points that can be relevant to your work and to the future of our application. So let's see what happens here. The agenda is to start from a demo in order to have a brief overview of all the features, the most important features that we have in C# 8 and, of course, in .NET Core 3. The reason for this demo is that we don't have enough time to see everything, okay? That's the truth. There are many, many things. So I had to choose the most important ones. And I decided to sacrifice something. So bear with me, I don't want to talk about all the features that has already been covered from other .next sessions in this edition and in other editions, so that you can see and watch the videos and compare your opinion about all these features and go on. So I want, this won't be a classical session with a kind of overview with all the features. You are advised, so bear with me that it's worth the pain to listen to this crazy man. So the C# features that I will a little bit deep diving is the read-only member instructs, which are very relevant to all the discussions that we had last year with read-only, the refs, and so on. So it's a kind of continuation of a long discussion we had to improve the performance of the application. The static local function, which looked like something impacting performance, but ... we will see later. And the default interface members, who generally makes every man cause a heart attack, because we are talking about adding body to the members inside the interface, which is totally scaring, and we will see. Also, with regards to .NET Core 3, we have super important features regarding the publishing option, which is extremely good for our application. Simple, effective, and good things to do. And load context, I will talk about it later, you will see. And since we are going to talk about load context, there is an edge case I wanted to, real use case, by the way, I want to bring to your attention. And so we will kind of make an investigation with the new tools, the new global tools that are now available to diagnose our application. And we will see in a moment. .NET Framework is dead, but long life to .NET Core. This means basically that you cannot use the new features in C# 8 with .NET Framework. And .NET Framework will be the very last version with the version 4.8. There will not be another version of .NET Framework. This is important to understand, because if you want your application to go on, to embrace the new technologies, the new features, and so on, you have to migrate your application to .NET Core, which is not a terrible thing, because you now have all the workloads that you need to migrate your application. So don't be scared about this, and we can discuss even later on all the standards. By the way, C# 8 and .NET Standard 2.1, so the latest .NET standard, this standard contract that allows the binaries to be reused across multiple frameworks, will not be implemented by .NET Framework itself because it doesn't have enough features inside the core CLR that permits to run these changes. And it's too risky to bring these features from .NET Core and put it in the .NET Framework because it could cause breaking changes, which we don't want because there are millions of applications deployed out there. So one of the main reasons for migrating to .NET Core is because now we have side-by-side deployment. And deployment is the key. And we will see in a moment what it means. The future is .NET 5, which, by the way, is .NET Core. It's just a renaming of .NET Core. And every 2 years, we will have an LTS. A predictable roadmap has been published by Microsoft, so you can see my slide, but even the official announcement from Microsoft. And this is the story, basically. So the future is .NET Core. Before going on C# 8 read-only members, I wanted to bring your attention to an application that I created on purpose for this session. And when we talk about leveraging all the new stuff, I want to talk about an application that is created with very strange things. So the first one is, of course, a console application. And when we talk about a console application, you really feel like a poor application, something that you cannot do many things. It's not very useful. But this is not the case, because console applications are very powerful, are the base to build, for example, Windows services or Linux services, okay? But you need always an infrastructure. How many times you wondered, how can I do logging or configuration and so on inside a console application? And it was not practical. For this reason, Microsoft created, lastly, a new template, which is marked in CS Project with this the SDK Worker, okay, which enables all the cool infrastructure taken from ASP.NET Core, even in normal applications, like a console. This means that basically we have this new object host that created the default builder. We can manage the lifetime of the application, saying that if there is Control-C, we want to be advised about the application being closed, which is good, because in a console application must know that is going to be closed. We can configure the logging, which is very useful, and then I redirected all the logging to the console, to the output window of Visual Studio. We can do many other things with the application configuration. And then there is the configure services that you know very well if you ever used ASP.NET Core. It's exactly the same paradigm, because there is the dependency injection that is playing, that is helping you. And the dependency injection is a power, because we now have a new service, for example, which is called configuration get section GitHub service, that is basically saying, hey, you know, every time you get this configuration section, I want you to bind, to populate an instance of GitHub service config, so that I can load the configuration. And not only I want this, but I also want to inject the configuration to all the other services requiring it. And so the same for the Twitter service. And then we have this singleton, we have this transient. The life cycle is basically the same we have in ASP.NET Core. And then I configured also a custom HTTP client, which is able now to understand I modeled a custom HTTP client that knows about Twitter. That's the point. At the very end, there is this service, this is the worker, which runs a lot of things. Okay, you say, it's interesting. There are many other things to say, like the application is able to manage its own life cycle thanks to this interface that I can obtain from the dependency injection. You know, every parameter that I specify in the constructor automatically is provided by the dependency injection, avoiding messing dependencies and very bad things that can happen. But you are already tired of this application. So I want to show you a wonderful new Gem UI application, which, by the way, is an exciting Windows Form application. And Windows Form is one of the workloads that has been moved to .NET Core, and WPF as well. One of the advantages of the leveraging is not just to have migrated the application, but there is more, because in the program CS, I adopted exactly the same paradigm that you have seen in the console in a minute. Substantially, I cut and pasted the template that Microsoft created for the console, and I adapted it for the Windows Form application with a lot of advantages there, because now you have the ability to create this host builder. You have exactly the same configuration logging. You can manage the user secrets, which I will not open in stage for obvious reasons, but you have managed user secrets here, because of course, in order to access to Twitter and GitHub, I have to provide my secrets, which are held in my user profile and not inside the project, because I don't want to commit them in GitHub, of course. And then the configure services give me the ability to have an additional configuration for the application itself, as well as the other configuration that we have seen a minute ago for Twitter and GitHub. I configured basically the same things that you have seen before, including the HTTP client. And then I had also this transliteration stuff, which is interesting. So basically it means, what if I want to configure the transliteration of the Russian language, because I come from Italy and the Cyrillic is not very practical to me? And so I basically said, okay, I have these settings that can be nothing or Windows. I have written here in order not to make mistakes when I type, or this other library. And depending on the value that we have, we can use the pattern matching in order to say, well, the transliteration type is a type that depends on the string. And if it's Windows, it's transliterator. It's a Nick Bureau instead is the transliterator from the other library. And this is one of the possible approach with the pattern matching, instead of a switch case and having to throw and blah, blah, blah. And this underscore is basically the default of the switch, default switch. Right after, we have this add singleton that adds the type. Of course, no transliteration is the kind of NOP for not doing anything. And then we have this injection of the form. The forms can be injected, but you have to be very careful, because if you want to open and then close, when you press the X on the form, it is disposed, right? So you want to reopen on demand. And how can you open on demand? By asking to the dependency injection, because if you make the new, you have to provide also the parameters to the constructor. So if we go to the form 1 with F7, so that we can see the code, you can see that I am not declaring the ability to receive the form for themselves, but a factory. And I created this factory in the service collection extension. And basically what it means, that when I have the service collection, that is basically the dependency injector, I register both the form as a transient, so that every time I request it, it gets recreated a new instance, but also the factory itself, so that I can have a factory that on demand can produce an instance of the form. I may have multiple forms if I want, or simply I close and reopen, I have a new, fresh form to reuse. And this is a good example. I left these comments on purpose in order for you to see the difference between passing the instance or the factory. And when you are at the point that click the button and want to manage the click, of course, you want to create an instance of this form before showing it. Otherwise, if it's disposed, it would explode. These are all the things that are very, very nice to investigate. One of the things that Microsoft did with this is that you can even have a beta version of the designer, which is, by the way, currently, one, very small, two, very limited, because it has a certain limitation. For example, you can't see my custom control in the middle. So instead of playing here, I created a parallel project where I can open this one with the old designer, because this project that is inside the designer folder is made with .NET Framework with the old Windows Forms, okay? But here I cannot have all the plus that I talked in a few minutes ago. So I have a designer. I can cut and paste the initialize component in order to bring all the stuff to my new skeleton. And finally, I can come back to this other interesting thing. So when I go to the tweet list box, I can scroll down. This is a derived list box, basically. And I want to manage by myself the ability to scroll. Why should I do things like that? The reason is that when the list box gets drawn, I want to draw in a special way. And this means that you will see if there is any item available. I want to take the text, the font, and then I have to create the brushes. And the brushes, of course, are disposable objects. And you know what? We don't need that strange triangle of the using, the nested using. You know, you have these triangles that is very large and is noisy. Because C#8 gives us the ability to simply say, okay, we have just a single statement that terminates here, and they will all be disposed at the first closed brace that we will encounter in the method. So, end of the story. Very, very clean. You just put using and forget, because at the end of the brace method, it will be closed. And it's fantastic. I mean, you now have the ability to receive, thanks to the Windows Approach, old times tricks that maybe those of you that are more familiar with the WPF doesn't remember, but there are the ability to provide this behavior for the scrolling. You may wonder, why should I have the need for that? Because there is another feature that is extremely interesting. So when I want the notification for the on-scroll and mouse wheel, I want to load more tweets. Of course, I cannot simply make load and then block the UI and wait from 1,000 tweets comes to my computer. It's crappy, we know that it's an old problem. What we want to do is that we want to use asynchronous methods, and Stefan has already shown the asynchronous enumerable, where you have a wait for each, and you can simply loop in an asynchronous way all the items that are coming down from Twitter. Okay? And I had to model this. So if you look at the implementation, I am simply saying, well, this is the account, And this is the starting ID that I want to download. And the initial is, of course, 0. And every time I have remaining items, this gets updated so that I can continue where I left off. And the idea is, when should I load the next? As soon as the scroll bar goes down. So when I close to the end, I load again the next. And this is the idea. So if we play and go in Twitter, you will see that load takes the first set of tweets. And then as soon as we scroll down, you will see that they gets reloaded. And then with the mouse gets reloaded and so on. There are no more tweets. And if we go to my account, I feel more comfortable because there is no Cyrillic there. You see that is continuously loaded, and we go on. Okay? But sometimes I also retweet in Russian, so that's a problem. Okay. Now that we have seen all this beautiness, now we have the app settings, and we want to, for example, to transliterate with this library, or maybe this one, okay? And we can relaunch the application. Blah, blah, blah. Twitter, .NET Const, and voila. I have no idea if this makes sense for you, but this is the end of the story. So Windows has an internal API that is aimed specifically to make transliteration. Don't shoot at the pianist, at the piano man. So I don't know if it's good or not, but this is one possibility. Okay. This horrible UI with the line, vertical line, is my design because I am not a designer. I'm an architect, so you can understand why. And basically, what we did is that we said we had a lot of problems with this library because the transliteration library in Windows, you know, you call APIs, you have the first thing that you can see is a yellow ribbon, a yellow triangle. This yellow triangle is super important because I am referencing a NuGet package, which is old, which the API codec is only made for the .NET framework, but we are using it under .NET Core. How is it possible? A different framework. So it is possible because the underlying API is also supported from .NET Core. And so just replacing the call, it works. Because there is a compatibility between the two. The binding works. It's not guaranteed, and that's why you have the triangle. But it's a good sign. It means that you don't need everybody to recompile everything. You need at least to test. This is fundamental. Of course, you are changing the CLR. At least the test must be run, right? So this is mandatory. And the other thing that I had is that I was not pretty confident that I cannot throw some null reference exception. And so I enabled the check for nullable reference so that I can avoid the reference type may contain nulls. And this results in a series of advices that I may receive from the compiler during design time. So you see the string with the question mark is saying this string can be null because I want to be null. But if I remove the question mark, I am saying, oh, this string cannot be null. And you will have all the warnings from the editor about this. This is not really a language feature. The language C# has been annotated, so allows the question mark. But most of the work is done far before. So it's something that goes to the IDE that is saying, hey, if you want, I can make some code analysis on your source file, and I will advise you that you are using, you are dereferencing a reference that potentially is null. If you make a check with an if A is different than null, then A dot, the compiler say, okay, you can go. But this is not something that happens at compile time. It happens only during the design time, when you are structuring your application. So, in my opinion, is super important, but not that, I mean, you just have to experiment, and you will get familiar with that in 2 minutes. It's super easy. Let's go back for a moment to the slides. We want to make a little parenthesis of this read-only member instructs. So, after all the revolution that we had with references and read-onliness in C#7, there was a missing feature. So we had the possibility on value types, where we are talking about value types, so on structs, the ability to mark the entire value type as read-only. This is important because, you know, the value type usually gets copied when you pass them as parameters. And so one of the most relevant performance hits is when you pass a value type, and this value type maybe is very big, and you end up in having a copy, and this takes time, and your application becomes slower. On the other side, if it is a class, goes to the garbage collector, which before or later will have to collect all the stuff, and you lose performance as well. So marking is as a read-only, just inform the compiler that he can make some trick and say, okay, you have this instance of value type, you want to pass there, but since you are not going to modify, I will not make a copy. And in some cases, the compiler is so smart that auto-detects those cases and understand that he can avoid to make the copy. So making the benchmarks is not that easy because sometimes you incur in these edge cases where the compiler is already super smart and understand not to make the copy. But we are talking about C#8 where the feature is telling you now, since most of the value types will need to make some changes to its state, you can mark even a single member. So for example, if you have get length, of course it is a get, but it's a method. How can I know it that is read-only? And so the idea is that you can mark read-only. You give a hint to the compiler, and we will have one, readability for your team, so the better maintenance, because nobody is going to add something that will store the length somewhere in a cache. And also you will inform the compiler that he can drive some crazy optimization in order to get more performance. If you try to modify something inside the read-only method, of course, you will have some either error or warning depending on the case. In the worst case, you will have the error, of course, but the warning is very relevant because it may allow you to make the changes anyway, but he is warning you, hey, you know what? I will make a copy. So the change that you are going to make probably will get lost because it will be on the copy and on the original instance. So help the compiler. Raise the, okay? If you have a vector that expose the get length in two ways, one with read-only, without, or without read-only, the bed is on the left, because of course the compiler cannot know that you are going to use a method that is will not alter the state. Therefore, since in is a reference read-only, which means basically it's a ref, like putting ref, but you are not going to modify the reference itself, okay? But the content is another, the instance that is pointed to is different. So you are going to pass the reference, you are promising that you are not going to change the reference itself, but since you invoke a method that is not marked as read-only, he will make a defensive copy. It's called defensive just because he cannot know. And in order to avoid any mistake, boom, copy. But if you use the one that is marked as read-only, of course, the copy will not occur. So this is helping the compiler to have a good optimization. Another feature, and I have a slide that is specific on an edge case, because that many of you, when saw for the first time the local function, said, oh my God, what is this thing? I don't want to write local functions. And so I kind of write something that will convince you that are not so bad in certain edge cases, okay? Originally, the local functions were just there to do certain things. So you want to isolate a method inside a method, a kind of nested method, okay? Which sounds so bad, by the way. And when you have this, the problem is that since the local function is an instance method, it can automatically capture the local variable, and this led to a number of discussions. There are issues with the performance. Not true. Sorry, it's not true. So capturing may have some problems, but only in very edge cases. In the most of the cases, there will be no performance hits there. But the most important thing is that capturing means that your code is going to be a garbage, because the next guy that will go there and try to read your code will not understand anything. So we have a static local function. I mean, I choose a very specific case. The static here is the core of the feature. So if you have a local function, you can mark it as static, which is the feature that is new in C# 8. But I didn't want to show a kind of local function that just adds 2 numbers, because it will be too stupid. And I wanted to bring to your attention another case. Then when you want to use the ref, so the idea of this method is to scale all the points that are inside this array by a factor, so multiplying everything. And I want to avoid the copies, of course. So I don't want to create a new array, duplicating all the points and so on. And since they are the value types, because points is a struct, of course I have to use the references, which is the core feature of the versions in C# 7, 7.0, 1, 2, 3. So what's the point of this? That if I want to play with ref and I extract these 2 lines and put directly in the method, it will not work just because it's asynchronous. You cannot use async await and ref together. The trick here is that, I can do it anyway. How can I do it? So I have a wait task delay just for demonstration purposes to avoid bloat of code. I have the loop, and I just call this local function, which say, okay, ref point, get ref, blah, blah, blah. And I can return a ref, and I cannot have a local variable here of type ref that is marked as ref. But I can immediately make the binding with the equals, so get ref equal, star equal factor, and it works. And it's so nice. You may say, why don't you extract that local function in separate methods elsewhere? And the reason is that I am doing a strong assumption in this method. And probably if anybody else is going to use this method outside this context, would find a kind of null reference exception, or will go index out of range, and so on. So I know what I am doing. I don't make any kind of boundary checks. I don't make anything just because I am using this constrained to this function. And I believe that this is very relevant. So if you use local functions, please use static local functions instead. And now we come to the heart attack. The specifications tells us that we now can use interfaces that have bodies on any interface declaration members. So we have methods with bodies. We can have properties with bodies. Ooh. And we can change the visibility. Ooh. Of course, they cannot contain constructors and cannot contain fields, because we don't want to an interface have a state. And oh my God, that's too bad. And one of the things that it's not yet available, that is been planned, that is on GitHub, I am inside the thread, by the way, is that the request, if you have a class that derives that interface and wants to override the method, but at the same time leveraging the base implementation inside the interface, currently is not possible for very good reasons. If you are curious, we can talk about it later on in the discussion zone. So, why? First reason, versioning, super important. So we want to change list of t by adding a new cool method. How can you do it? Are you going to break the entire word? Okay? But I can add a single method with the body, and this is not breaking anyone. But if your class is not going to override it, just will benefit of the base implementation only if the object is used explicitly, that is casting, with the interface. So if you make a new class, then dot, you will not see anything. But if you say new class and then cast interface and then dot, okay, you will see it because you explicitly required the interface. Number two, interoperability with other languages supporting it. That's super important because we live in a mixed world. We want our application can go and play well with others. Many companies that write libraries want that these libraries can be written in many different languages because it goes on many different platforms. And what if I have to ship my library on .NET and then on iOS and then Android? I have to, at least the patterns should be pretty much the same, otherwise I get lost very quickly. Number three, the most important, the one that I love most. This is just the beginning of traits programming. Traits is super important because give you the ability to make composition of behavior. It's very common in C++, for example. So you may define an interface with a set of methods, another interface with another set of methods, and then inheriting these methods as it was a multiple inheritance inside an object. You have composed the behavior of the object, and we will see it in a second. For the versioning, the good news is that even if I have assembly 1 that is going to change from this implementation to this one, even if the assembly 2 is not going to be recompiled, I will swap the DLL for assembly 1 under the hood, and I will see the change coming out. This is an interesting behavior. This is, by the way, what you would expect. You can even re-abstract the default interface body. So if you have a member and you provided an implementation and you say, oh, no, from now on, this hierarchy don't want to see the base implementation anymore, you can re-abstract it. I still have no use cases for this. It's too new, but we can discuss it. So traits composition, and the best way to see traits composition is going back to our sample. And I will leave then the example and the slide for your future attention. So basically we have this composed transliterator, and I said, if you are going to provide all the possible permutation of the interface, how can you do it? Because there are multiple transliterations. There are not only the Russian one, there is the Bulgarian one, there are many others. So I said, should I define an interface with everything and then throw a not implemented exception? Or should I provide many interfaces and then deciding to implement singularly one on the other? It's boring. I mean, every time I have to do a manual implementation, it's something that I didn't like. I mean, it requires a lot of work. Works, but it's not practical. What about something like that? I mean, I said I have this implementation. Don't look at this at a pure interface. It's just a type that provides a single method in a stateless way so that you can provide this functionality. And then this other one, which is the reverse. Now look at this and say, okay, if me is Cyrillic to Latin, let's do it. If me is this other, let's do it. Or if you prefer, we can use Transliterate using the pattern matching, okay, and say, if me is C and the conversion results in something that is useful, so the input and the output are different, then I return the result, and so on. And this is a possible use case when you want to kind of compose the behavior of an object, just aggregating it. Okay? I know that we will discuss that later on. I am already desperate. Okay. Let's go on. On the publishing option, the good news is now that when you compile .NET Core 3, any application, you obtain the so-called framework-dependent deployment, which causes to have an exe. So we already have the host. In the past, we only had the DLL, and you have to manually publish something. Now they changed the default in order to have the exe immediately. This is very good, because when you are working by running processes and so on, having to run by .NET Run or having to publish it manually is kind of boring. A very nice option is publish single file. You can aggregate all your file, all the dependencies, everything inside a big fat exe. And you see the sizes. I will not repeat the slide. I mean, it's there. It's fat, it's big, and you have the chance to choose between the self-contained. Self-contained equal true, by the way, implies that you bring with you even the core CLR. So you don't need to install anything on the deployed machine. Basically, it means that if that is true, which is the default, you have on a USB key your application with a single file, you plug in another Windows machine or Linux machine, and it runs. Boom, fine. And we are there, okay? Another good option is trimmed. Trimmed is a good thing that comes from Mono, from the linker. Requires at the moment self-contained equals true. There are requests to avoid the self-contained to true. And basically it means, please remove all the code. I mean, not the assemblies. I mean, Inside an assembly, maybe I use 2 methods. Why should I bring with me everything? Okay? So trimming means cut with the knife and say, I want only the things that I effectively use. But if you do nasty thing with the reflection, of course, there is some problem. So you have to test your application once you have trimmed it and verify that effectively the publisher understood that you need that method. Okay? If he is not able to understand which method is needed, you can instruct them it with trimmer root assembly and trimmer root description. So pretty easy. Just try it. And then the AOT compilation, which is extremely relevant for a lot of scenarios, like lambdas or Azure functions or publishing to a Raspberry Pi. It's relevant to the Raspberry Pi because the Raspberry Pi have the USB bus and it is very slow in reading and writing files, okay? Not just because it's ARM. And this means that basically you have a not so efficient compilation, okay? Because it's ahead of time. It means that it will be produced on my PC without knowing if your PC is better, maybe has a better CPU, has many other optimization that can be done at runtime. And so I have to say, no, I cannot say anything. I have to take the worst possible case and compile so that can run everywhere, okay? Also, there is a huge difference in comparison to NGen, because NGen made assumptions since compiled all the framework together and new fixed addresses and so on. But the AOT cannot know certain things. So there are anyway methods that will not be compiled at all. And the jitter will still be needed. So how can you survive to all this information? The idea is that now, before the tyrant compilation, you had a situation similar to this. So at the application boot, the usual JIT, the one that is super cool because with our JIT, the Ryu JIT is extremely performant, but it's slower. Just because it makes a super optimization, it's a bit slower than expected, especially if you run in a Lambda or in other scenarios like that. So when Microsoft started with .NET Core 3, said, let's split the compilation in 2 tiers. The first tier, it happens at application boot time, and the other at steady state. So once the application is ready to go, so the most of the things has already been done. And depending on the case, it happens different things. The first is that if you publish the ready to run, so the AOT compilation, the methods that has not been compiled by the IoT will be immediately compiled with the JIT, with the slow JIT, let's say, at application boot time, of course, because they are not there, so they are required. You have just IL. But for the part that has already been compiled by the AOT, they will be compiled later on, after the boot. So during the boot, your application will be run with the code produced by AOT, resulting in a better performance during boot. So it's speedy, it goes, go, okay? But as soon as application is up and running, and it's, let's say, slowly going on, some of the methods can be recompiled. We will be back on the hot path in a moment. Then you have an option that is not turned on by default, that is tiered compilation quick JIT. So if you want to leverage the JIT and not AOT for good reason, maybe because you run your application on multiple platforms and you don't want to compile for Linux 64, for ARM32, for ARM64, Windows 64, it's a nightmare, right? And so you want to enable the quick JIT. So then with the quick JIT, you start very fast, but with code that is not very well optimized. And later on, only for the hot paths, you will have a rejitting again, so will be recompiled again with the quality that we are used it normally. Finally, you have the possibility to mix everything and say, okay, I have AOT. I want the quick JIT for those methods that were not compiled initially, and also I want them to be recompiled on tier 1 if they lies in a hot path. If you have questions on this, we will discuss later on. Okay, what is a hot path? Simply a counter, a call counter that after reaches 30 times, immediately after, it gets queued in a separate thread and gets recompiled. That's all, very simple, nothing terrible. There are two tools to diagnose the jitting problems and so on. PerfView, you know, the usual PerfView, and the R2R dump, which is an analyzer of the exe that is produced by AOT. In the future, maybe we will have profile-guided optimization. That means training the compiler to give better code. Load context. I will switch on the example, and then I will leave you the slides just for your own reference. What does it mean? It basically means that now we have those load context that enables you to make the same, to reach the same goal you had before with the app domains. In the past, we have app domains in order to unload the assemblies that were loaded in a different app domain. But the app domain unloading was forcibly. I mean, if I close an app domain, everything that is there is closed immediately. Instead, the assembly load context is something that is collaborative. So it's something that you have to cut your reference to the other load context in order to see everything going down. And we will see this example, which is pretty nice. So what it means that I have some add-ons that you see here, and I want to load them inside a separate load context. For this reason, I derive from the load context, assembly load context, and create my class that is add load context. The good thing is that once I give the path of the add-in, automatically this other object, this assembly dependency resolver, takes care of analyzing the dependencies with the depth.json file and understand if there are other files that depends on the add-in and must be loaded in the separate context. So you should not take care of all the dependencies of the add-on. This guy can make it for you, so it's very simple. Also, keep an eye on this weak reference because we will see in a moment. We want to know if this guy stays alive or not, and when there is this property for this purpose. As soon as we load a request for loading happens, we receive the assembly name. This is called by the core CLR. It's something that is called by the core CLR. It's not up to us to call it. And we ask the resolver to resolve the assembly name, and we have the assembly file name. At this point, we know where the add-on is, and we can load it in memory. That's it. And if we want, we can also make the same thing for native, so for the p invokes, which is pretty new and very interesting. I mean, it's something that is extremely desirable. Okay, so let's see what means in terms of client code. This means that we run in two steps. The first is loading, and the other is unloading. The loading is very simple because we take the name of the add-on here, and we load on the context this add-on, okay, we subscribe to the unloading event, which is not very useful because it will happen exactly when we call unload, not when the real unload will happen, because it depends from the GC. And then we have the ability to call whatever we want internally to the add-on. So we work with the add-on. This is what is meant to. I have all this print all context so that when you will access the source of the samples, you will have the proof of seeing what is inside each context and the app domain. At the very end, I hit the unload method, and finally, with the flush, which is horrible code in calling multiple times garbage collector collect, as Microsoft recommend 10 times. I don't know why, but there are speaker friends that tells me that it's not appropriate. This guy goes down. Okay, so basically we brought the assembly load context there, and then boom, push it down, and it's pretty cool. So if you want to see it running, I can say that we can rerun the demo in right after. So we already talked about this good thing, but there is a case, and I want to show you exactly that when you want to load a dependency and this dependency does not go down, like JSON.NET is an example because we use the type descriptor, you have to use the diagnostic tools. And this diagnostic tools is .NET dump, which allows you to collect a dump and to capture dump live from your application, and then analyze with the same command that you used in the past with SOS, if you ever used it, okay? So the idea is that I want to use the dump heap minus type load allocator, which is the magic string that you want to search when you want to detect a leak on an assembly load context. This is Microsoft telling us, okay? If you have a leaked assembly load context that the garbage collector cannot go down, who is taking the reference to this guy? I want to find the responsible. Okay, maybe it's an address holding a register, maybe a static field, which is classically one of the reasons for the leaks. So the next step is to see all the routes for this guy, and you have a long list. In this case, you have static elements. You have, when you have a register, typically means a local variable, which is not very relevant, so you can ignore it. And finally, you get here and say, oh, it's this guy. And you basically find who is the responsible. But there are more trickiest way, because if the address is hold inside one of the field, you cannot loop all the object like you do in WinDBG to find where is this type. And .NET Dump currently cannot be automated in any way. So I had a very nasty case with type converted that is used by JSON.NET that cannot be found that easily. So you see manual search. This dump obj, I had to know it because I looked for it in a different way. And the last demo I want to show you is there are two tools, basically. This one is really stupid. I mean, I created a program that ran as an exe, .NET dump, analyzed the output from the IO stream, and has a number of parser for each command, analyze the text, and see what happens. I mean, the operation is so automatic that you can make it as a separate tool in order to find the leak. And when you go at the very end, say, okay, the analysis is complete, and this is the responsible of your leak. Bang. It's really straightforward. But I understand that you don't want to mess with the output because we are used to use CLR libraries instead of the output of the stream. And so if you prefer, we can use directly CLRMD that makes a similar analysis, but instead of giving just the magic, I really wanted to print all the steps. And we arrive exactly on the same result. This is basically the same output that can be produced by .NET dump, but made manually with CLRMD, so that we have these results. Well, we came to the end, and I want to leave you this cheat sheet so that you also know which are the commands to type. And I also want to take advantage of thanking you very much to be with me for this hour. I hope you enjoyed the session, and please reach me in the conversation zone for any question on these topics. Thank you very much.